Okay, good Friday morning, friends. Welcome back to the Urban Ecology Center's Backyard Naturalist series. My name is Tim, and I will be your host today as we look up into the sky to explore the connections of the connections that our backyards have with the heavens, with the skies above. Backyards across the globe have direct access to the sky. Even in urban environments with a lot of ambient light, we can still often see the brightest objects in the sky. The brightest object is the sun. And we had an episode a few years back, the prodigal son on the sun. The second brightest object is the moon. From our perspective, we had an episode a couple of years ago called High Moon. And now the third brightest object that we can see from the Earth is the planet Venus, which we will explore now. So I hope you're comfortable, sit back, relax, listen to the stories that Venus has to tell in episode 44 of season 4 of the Backyard Naturalist, Ishtar. With a nod to PBS, this program was made possible thanks to the financial investments from viewers like you. If you like this program or like that it exists and want to help keep it going, we would love it if you would consider purchasing a subscription for the 2023-2024 season 5. We'll soon be sharing details and links, but an annual subscription is the best way to support this community. Comes out to about a couple bucks a week. And so thank you to all past and current subscribers. We have a subscriber appreciation hike this Saturday, as well as a subscriber end of year party. And as a subscriber, you don't have to worry about registering. You just magically get a link in your inbox about an hour before the program starts. Tomorrow's field trip will be a morning trip. Usually they're in the afternoon. We will meet at the amazing Falk Woods on the south side of Milwaukee County, one of the best habitats for amphibians, and just a fantastic ecological system to explore. Details will be sent to registrants this evening, and if you have any questions, please don't hesitate to contact me. So we are looking skyward for today's Backyard Naturalists, and while our eyes are trained to the skies, we'll quickly check in about some of the space exploration news that we've been following lately. So last Saturday, the day after last Backyard Naturalist, the Euclid telescope successfully launched on a SpaceX rocket. The mission is from the European Space Agency, designed to tackle some really interesting issues like the nature of dark matter and dark energy in our universe, and a deeper understanding of how gravity works. Does it work how we think it works? And our understanding of how the universe expands, the expansion of the universe changes over time. Lots of super interesting information. Again, launched from Cape Canaveral, which is near the equator, we'll talk a little bit about why launches happen near the equator. And then on July 14th, which is next Friday, the Indian space program is scheduled to launch the Chandrayaan-3 moon mission. So back in 2019, you may remember that the Indian space program successfully orbited a spacecraft around the moon, and that orbiter is still there. But its attempt to land a rover to explore the lunar surface ended in a dramatic crash and some interesting politics to try to save face, and some crowdsourcing that people that can see images from the moon, that actually crowdsources found the wreckage of the crash, and then so the government had to admit that yes, it wasn't successful. So they're trying again. They already have the successful orbiter, and this time they're just trying to land a rover on the moon, and fingers crossed it'll be successful, because the more we learn, the more we know, and that's a good thing usually. But today we're talking about Venus, and there were several sources of information, but a good chunk of it came from Stuff You Should Know, one of my favorite podcasts, Josh and Chuck. I encourage you to listen to, subscribe to them. It's just one of my favorites. And there are a lot of reasons why our understanding of Venus is important to humanity, no less, and also why this is a good time to be talking about Venus, and we'll unfold some of the layers during the course of this talk. But really, my takeaway is that Venus, it's an object in the sky. We see it up there, but Man, it's a really freaking cool planet. And not temperature wise, it is not cool. It's ridiculously hot, but it's awesome. Except I think awesome is a terrible word because awesome maybe implies there's some awe. Venus is full of awe, but then that word would be awful. So I don't understand how that English works, but it's amazing. It's an amazing planet. And we'll start our amazement with a story. And a version of this particular story has been told as a Dreamtime story in Australia by the Yolnu people and has likely been told for 65,000 years. The creator spirit for the Yolnu was called Barnumbir, and Barnumbir led humans to Australia from her island of Baralku. And as she flew across the land, when she reached Australia and she flew across the land, she was creating places, creating features, creating animals, and then she was also naming all those animals and places, naming water holes and rivers and mountains. And she did this through song. And so her path is called a song line, and it's written on an oral map, which is just a great way to capture these stories. Her sisters were well aware of her wanderlust, just wandering around, and they were worried that she would get lost. And so they ended up tying a rope around Barunumbir, not to keep her prisoner, but just they wanted the rope to be long enough that she could still explore, but short enough that she wouldn't wander too far that she would get lost. And so Barunumbir is the morning star, and the morning star never wanders too high in the sky because of this rope. And then after she brought these people to Australia, she continues to work to guide people to the heavens when their time on earth is over. So when the body dies, the spirit of Barnumbir, the spirits of the deceased can follow the rope that the sisters tied to her to lead to the heavens. And so this is the basis for the morning star ceremony, which is still held today by the Yolnu people in Australia. And they have to wait for, this is obviously the goddess is, or the deity, the spirit is tied with Venus. And so this ceremony can only take place about once every 1.5 years when Venus is in the right place and there's poles. So ever since humans existed, and very likely since before humans, our Homo ancestors, people have noticed Barunumbir, the planet we call Venus, and there are many stories and deities associated with Venus from all corners of the globe, because paying attention to the stars and planets has been important to people all over the world. So Venus has been known and noticed by humanity for as long as we've been around. And one of the reasons for this is Venus is super bright. So, you look at this picture and say, well, that's not super bright, Tim, but if you consider that this photo was taken outside of Manhattan, and the only two objects you can see are the moon on top and Venus on the bottom, Venus is cutting through all that urban light pollution. And so no matter where you live on Earth, it's likely that you can still see Venus. And if you happen to be in an area with dark skies, then Venus really, really shines. And like I said, been paid attention to by humanity for as long as we've existed, likely. Another story of Venus comes from the Babylon, and we go back to 1660 BCE, almost 4,000 years ago. And in this tablet, the Babylonian king Melishapak is presenting his daughter to the goddess Nanaya. And in this depiction, we see those three brightest objects in the sky. So they saw them back then, we see them today. The sun is obviously the brightest object, and that's on the right represented by the god Shamash. The moon is the second brightest object in the night sky, although it is bright because it's reflecting light from the sun. And the moon here is that middle object represented by the god Sin. And then the third brightest object in our night sky is Venus, which is also reflecting light from the sun. And so here it is on the left, represented by Ishtar, the goddess of love and war. So Venus has often been thought of as a star because it is so bright. Ishtar is the god, and it's represented by an 8-pointed star. And here's the symbol has gone through various iterations through time. It was on an earlier version of the Iranian flag. And so Venus has been important to cultures around the world again because astronomy was important, and you could see it well because it was so bright, no need for telescopes. And then the other thing that influences our relationship with Venus has to do with the fact that it's a planet that is closer to the sun than our planet Earth, which means that its orbit is enclosed in our orbit, which means from our perspective, Venus can never get too far from the sun. So that's the rope that is keeping it from getting too far in the sky. It's why it can only appear in the morning before the sun rises, or in the evening after the sun sets. And this is why many cultures thought that Venus was actually two different stars. And I'm using the term star here because that's what it was thought to be for so long. So it's often two different stars. So in the opening story of Barunumbir, that had to do with Venus as the morning star and the morning story to the Yolngu people of Northern Australia. But they had a different story about Venus when it was an evening star. And then it was named after Jirpun, whose spirit was a rude old man, and it was called the laughing star in the evening. So they had, even though it was the same star, same planet, they named it after two different spirits because they thought it was two different stars. To the Greeks, Venus as an evening star was called Hesperus and Vesper. And when she appeared that's when she appeared in the evening. But when she appeared in the morning, she was called Phosphor or Lucifer, or the bearer of light. So in our fireflies at night, the chemical luciferase is the light-bearing chemical in the fireflies or the lightning bugs. Venus is the only planet mentioned by Homer in the Iliad when he calls her Hesperus, the fairest star in the heavens. So again, because of the nature of where it comes up in the sky, it was always, for a long time, by many, thought of as two different stars. That doesn't mean that other cultures understood, that relationship and that it was one. But in the Western world, it was about 500 BCE. That's when Pythagoras said, hold on, everybody, Venus is actually just one star that we sometimes see in the morning and sometimes in the evening. So let's agree to give it one name. And the Greeks said, okay, we'll call her Aphrodite after the Olympian goddess of love, beauty, pleasure, and procreation. And that worked for a little while. But then the Romans came along and said, nope, we're going to call her Venus. That's our goddess. That's essentially just the Roman counterpart of Aphrodite, the goddess of love. So there are mountains and mountains of information, books, websites. There's a whole lot of stuff about Venus's relationship in culture, and it's super fascinating. And just all the different ways that Venus has been represented through time and through cultures. It's interesting to me, but in that a lot of times Venus is associated with beauty. As we kind of now make this transition to talking about Venus as a planet, it's throughout cultures, it's named for love and beauty, in particular kind of a feminine beauty, a particular kind of beauty that's delicate and gentle and kind is how it's kind of described, which is pretty interesting because the actual surface of the planet Venus is much more accurately described as a hellscape. There's absolutely nothing that is delicate about the planet Venus. So if you were to be transported to Venus, and that'd be the only way you could get there because there's no way you could make the journey, your body would essentially melt into a puddle and then boil and vaporize. The sulfuric acid would vaporize your bones and teeth. There'd be absolutely nothing left of you. So in case you were lulled into this depiction of Venus as lovely and beautiful as has been the stories over time, I still think it's lovely and beautiful, just not in the way that, people have depicted it. To me, it's lovely and beautiful in a powerful, in your face way. And maybe the early modern astronomers recognized this when we first started exploring the planet Venus and started naming features after you know, a different kind of beauty. So this was after women that were associated maybe more with power. And so there's a crater named Sacagawea and a canyon named after Diana, which is the Roman goddess of the hunt. And when we started exploring Venus, we found it was a terrestrial planet, very similar to Earth, often called Earth's twin or Earth's toxic twin. It's about the same size, a little bit smaller. It's about 80% of the mass of the Earth. And just like the moon that reflects sunlight, Venus has phases based on the position of the sun and Venus relative to Earth. And it was Galileo then that first noticed this, because we can always see Venus without a telescope, but to see the phases, you do need a telescope. And so that's where Galileo's contributions came in. A good way to describe Venus is that it's a very slow roller, unlike the Earth. The Earth is rotating pretty quickly around the axis. Venus is rotating very, very slowly, almost imperceptibly slowly. So the Earth takes 24 hours to rotate once on its axis, what we call a day. It takes Venus 243 Earth days to rotate once around its axis. So the Venetian day is equivalent to 243 Earth days. So if it's Monday on Venus, that sucks because it's going to be Monday for a long time. Venus has the slowest rotation of all the planets in the solar system, and this tortoise pace of a rotation has a couple of major effects. First of all, unlike Earth, Venus is an almost perfect sphere. The Earth rotates so fast that centripetal force causes it to bulge in the middle, just like me. The Earth is more of an elliptical shaped planet, wider in the middle, and that causes the Coriolis effect. It's why we launch the SpaceX rockets from Cape Canaveral closer to Florida, even if you're a European Space Agency. It's that fast rotation of the Earth that gives us our strong magnetic field. It's the molten mantle rotating around an iron core. So if we didn't have this strong rotation, it would affect space agencies, it would affect the weather patterns, the Coriolis, it would affect our magnetic field. That's rotation is what really influences those. Venus also has an iron core like Earth surrounded by a molten mantle, but it doesn't have that fast rotation. So functionally, there's really no magnetic field on Venus. There is a magnetic field because of that slow rotation, but it's 15 ten-thousandths of 1% of the strength of Earth's magnetic field. So essentially, there is no magnetism to speak of on Venus. The other unique thing about Venus's very slow rotation is that it spins in the opposite direction of all of the other planets in the solar system except Uranus, which is kind of tipped almost, you know, has a kind of a weird axis of rotation or different. So from our perspective, Venus and Uranus are rotating backwards, and they're the only planets that do so. So since we started to pay attention to Venus, there are a few theories as to why Venus rotates so slowly and in an opposite direction of most of the other planets. The first theory is that Venus initially rotated counterclockwise, just like the Earth, but then it collided with a massive object that literally knocked the planet upside down, essentially flipping it over. So then if it's rotating counterclockwise and you flip it over, all of a sudden it's rotating clockwise. So that's one theory as to how Venus is rotating the opposite direction. A second theory is that, again, Venus initially rotated counterclockwise like all the other planets, but because it's so close to the sun and it has an extremely thick atmosphere, the sun creates gravitational tides of the atmosphere. So the moon creates tides in the water of the Earth. The sun creates tides in the atmosphere, and the atmosphere is so thick and that gravitational pull is so strong that slowed down and changed the rotation of the planet. That's the second theory. And then the third major theory is that Venus used to have a moon, but then essentially Earth got jealous because the Earth didn't have a moon. And so we used our bigger gravitational pull to kind of steal Venus's moon out of its orbit. And then we thought, oh crap, this moon is coming right at us now that we stole it. And it caused a massive collision on Earth, which then likely formed our own moon on Earth. So this massive event had a huge effect on Earth, but then it also had an effect on Venus. And there's evidence supporting all three of those theories. But then this massive event would have also impacted the rotation of Venus and potentially caused it to go backwards. Whichever theory holds the most water, there's no longer water on Venus. NASA, regardless of what the theory, NASA made a startling discovery about the rotation of Venus, in that its rotation is slowing down dramatically. So in a period of 16 years, we were able to measure the rotation of Venus slowing down by 6.5 minutes. So in comparison, the Earth's rotation is also slowing. So that's 6.5 minutes per year in comparison with Earth's rotation, which is slowing at 1.8 milliseconds every 100 years. So both planets are slowing. Venus is slowing at a much faster pace. We're not going to notice the Earth's slowing in our lifetimes or hundreds or thousands of generations to come. Humans will probably never notice it, especially at the rate we're destroying ourselves. But this observation does give some support to the idea that Venus used to spin counterclockwise, but then atmospheric forces slowed it down dramatically, caused it to start spinning clockwise. And now those same forces are slowing it down again to the point where it might start spinning counterclockwise again. It's like if you have a playground swing and you kind of wind yourself up around it, you twist yourself up so the chain gets shorter and you let yourself go, and then you start spinning really fast. And then at some point, the momentum caused the change to start spinning in the other direction, and you kind of spin that way, and then it slows down and you kind of go back and forth. And then if you're me, that's when you get up and throw up, because I do not do well in spinny motions. But that could be what's happening with Venus, is it just kind of spinning one way and then spinning the other way. And that might cycle over time. And that supports that idea that it's the atmosphere that's really kind of affecting the spin. Some more cool Venus facts. I mentioned that it takes 240 Earth days for Venus to rotate once around its axis. But given how close Venus is to the sun, it only takes 225 days for Venus to revolve once around the sun. So the Venetian day is longer than the Venetian year. So in that long Monday at work, you might actually celebrate your birthday twice. In fact, you'd celebrate your birthday every day on Venus. And then every once in a while, you'd have a second birthday in the same day, because the year is shorter than today. But then a kind of interesting perspective is actually if you lived on Venus and you did kind of like how we do on Earth, where we count the day, let's say from sunrise to sunrise. If that was your definition of a day, then one day on Venus would be 117 Earth days from sunrise to sunrise, based on that kind of combination of rotation and revolution. So then maybe that Monday at work doesn't seem as bad anymore. Like Earth, Venus has a basaltic crust formed by volcanoes. There are no plate tectonics. Venus has more volcanoes than any other planet. They have about 1,600. There are mountain ranges on Venus as high as Mount Everest. There are highlands the size of continents, South America, Australia. The gravitational pull of Venus is very similar to Earth. So a little bit lower, but not enough that if you were transported to the surface, you wouldn't notice the gravitational pull. You would notice a lot of other things. The atmosphere is so dense that if you somehow made it to the surface, you'd feel a pressure 90 times the pressure you feel on Earth, which is the same as being a kilometer deep in the ocean. And which seems really, really extreme, and it is. But then from another perspective, the deepest scuba diver ever has gone about a kilometer down in the ocean. So in that extreme moment, that scuba diver was experiencing the pressure that you would experience on the surface of Venus. But yeah, don't try that at home, please. Extreme environment for sure, so pressure, and then also temperature. So when humans first explored Venus with flybys and equipments, we estimated the temperature was about 300 to 400 degrees, super hot. But recently that estimate has almost doubled, more than doubled. We now estimate that the temperature, we've recorded temperatures as high as 880 degrees Fahrenheit. That's hot enough to melt aluminum. No, so no tin foil. It's hot enough to melt zinc. It's hot enough to melt lead. So even though Mercury is 23 million miles closer to the sun than Venus, Venus is by far the hottest planet in the solar system. So Josh Clark mentions that there's a astronomer at UC Boulder, Kevin McKedrick, who said, if you want to know what it feels like on Venus, get a hot plate. Put your hand on that hot plate. Again, please don't try this at home. Put your hand on that hot plate until it turns red. Then have someone on a truck drive over your hand on that hot plate. That's what it would feel like if you were transported to Venus. So not a place you'd want to hang out. And humans, it makes it hard to explore the planet. Humans have been sending probes to study Venus for decades. The Soviet Union was one of the first major explorers, and the US and some other countries. We've been sending probes to study Venus for decades, and the first ones were disastrous because the probes could not make it into that extreme environment. They just kept melting, disintegrating before they could get any information. But eventually, we engineered probes that could temporarily withstand the conditions. There's no permanent presence on Venus. It's always temporary. So with the modern technology, we were able to start gathering some data, but even though we've done this many times, the longest that any space probe has lasted, we've had successful landings on the surface, but the longest any space probe has lasted on the surface is 2 hours before it completely disintegrates. But that's enough time to transmit some valuable data about the atmosphere, about the crust. They've even transmitted audio files from the surface of the planet, so we know what it sounds like on Venus. But yeah, Venus is a hellscape. If the extreme temperatures and pressures wouldn't kill you, the atmosphere is essentially made of battery acid, along with, it's mostly carbon dioxide, nitrogen. There's a high concentration of sulfuric acid in the clouds that would burn your skin, cause your lungs to explode. Isn't this wonderful? And then if that's not enough, the massively thick atmosphere is so volatile that the storms there are just, put any storms we can have here on Earth to shame, way more intense than anything we have on Earth. The clouds in the upper atmosphere, where there's a lot of lightning storms, those clouds in the upper atmosphere rotate around the planet once every 4 days. That's really fast. The winds on the surface of the planet are going at about 3 miles an hour. So you have extremely fast upper atmosphere, extremely slow lower atmosphere winds, and that's the recipe for huge vortices, vortex, tornadoes. Even though they don't have that rotation from the planet, but you have a very strong rotational difference between the upper and lower atmosphere. So those upper atmosphere winds alone, just the winds, are way stronger than any tornado, than the strongest tornado we've ever had on Earth. So massive storms, constant lightning. There's an extreme hurricanado that's been raging over the South Pole since as long as we've been paying attention, and it's still going. So just not a great planet to hang out on. And this is where kind of this real cautionary tale begins, and it really hits its home. This is why it's extremely important for us as Earth dwellers. Venus wasn't always like this. For billions of years, Venus was likely a habitable planet. The evidence supports that it had very moderate temperate climate, had a very moderate temperate climate. It had oceans and rivers and streams for billions of years. Venus might have been a planet that not only supported life, but could possibly have supported life as we know it here on Earth. The atmospheric conditions might have been right straight out of a Star Trek episode. They get off and they can breathe the atmosphere. And again, the evidence supports that this was the case for billions of years. So what happened is the story might sound familiar. The greenhouse effect is a process that is important for life here on Earth. It makes life here on Earth. It makes the planet habitable. We have an atmosphere that surrounds our planet. And when light energy from the sun enters our atmosphere, some of it is converted into heat. So it's infrared energy. And if we didn't have an atmosphere, that heat would just bounce back into space and be gone. But because we have an atmosphere of greenhouse gases, which is a good thing, some of that heat is captured by the atmosphere. If we didn't have an atmosphere, you'd have really wild temperature swings day and night like they have on Mercury. So really hot days, really cold nights. But the atmosphere kind of acts like a blanket to moderate those temperature extremes. It kind of holds in some of that heat. And that's a good thing. And it can be a very stable thing. It can be maintained for a long time. The problem arises when the amount of greenhouse gases in the atmosphere changes in either direction. And in particular, if the concentration of greenhouse gases in the atmosphere rises, you can reach a point where you get a positive feedback where the atmosphere traps more heat and you're still getting this continual input of energy from the sun, which is fueling that heat gain. So you get a positive feedback loop, positive as in the temperature rises, not as in like a good thing positive. And this is very likely what happened to Venus about 100 million years ago. Whatever, if it was the volcano, something changed the atmosphere enough that the greenhouse gases increased. And as the atmosphere got hotter and hotter, the positive feedback fueled hotter and hotter temperatures. And then those surface waters, those oceans, the lakes, the streams, they boiled off. And then the liquid water became atmospheric water vapor, which is a greenhouse gas. So that made the system even stronger. And then it was so strong that the water vapor in the atmosphere was broken up by radiation, and the hydrogen from the water was sent into space to be lost. The oxygen stayed around and started combining with carbon that was in the atmosphere. Now all of a sudden you have this massive increase of carbon dioxide, which is one of the worst greenhouse gases. So it got so out of control that today you have an atmosphere that is about 96% carbon dioxide, and likely was at one time was very low in carbon dioxide. And not only is it 96% carbon dioxide, there's no water left, virtually no water left. There's a tiny trace amount of water, but the water's gone. You have, the nitrogen, sulfur dioxide, but 96% of it is carbon dioxide. So because the atmospheric greenhouse gases in Venus passed that critical tipping point, Venus went from looking like this, we think, and this is this cautionary tale that we are all experiencing and witnessing. It went from looking like this to looking like this. So we've understood the perils of global warming, and we only have to look to our twin planet for even more supporting evidence. It's why it's important to study Venus, especially since we don't really know what that tipping point actually is. We currently have an atmospheric percentage of carbon dioxide is at 0.04%. 0.04% on Earth, 96% on Venus. But our carbon dioxide is rising rapidly. And some scientists already fear that we passed that point where if we do nothing, this positive feedback loop will continue and our planet will be well on its way to looking like Venus. Starting with more extreme storms, which we're already getting, more record-setting heat, which we're already getting. We're experiencing a point where our oceans are growing because of the melting glaciers. But if this continues, then the water vapor from that ocean is we're going to start losing our surface temperature, our surface water. And eventually, you know, we could lose surface water altogether. I'm pretty sure we don't want that. Evidence supports this. I mean, this does seem like a gloom and doom kind of thing, but the science supports that if we do nothing and continue to put more greenhouse gases in the atmosphere, this is the path that Earth is on. So, you know, we don't know what that tipping point is. We don't know where the point is where we have enough by stopping putting more things into the atmosphere and more greenhouse gases. We don't know what our technology will be to help reverse this, but at some point that positive feedback loop is going to just wipe all of our potential possibilities away. So we need to continue to fight and fight harder to reduce the greenhouse gas emissions. I personally would like to keep Earth looking like Earth, a place where I can relax and learn, and a place from where I can still watch the beauty found in Venus. And it just so happens that 2023 is a great year for watching Venus, and today is a great day for watching Venus, because today, July 7th, Venus is at the brightest it will be. It's going to be a magnitude of -4.7, which is really bright. So today is the brightest point. I strongly encourage you to go outside when the sun sets tonight. It will be in the evening sky, setting about 2 hours. So from sunset to about 2 hours after sunset, you should be able to see it. As the weeks go by, the window for seeing Venus in the evening will be shorter and shorter. But as we know, it's an evening star and a morning star. And so in a couple months, it's going to reach peak brilliance again as a morning star. So on September 19th, that'll be the equivalent of this July 7th peak brightness. And so if you're a morning person, you can go out in the pre-dawn sky on September 19th and see peak brightness and Venus. And then on November 9th, there's going to be a spectacular Venus and moon pairing. And on December 25th, Venus is going to shine like a brilliant star in the east, rising nearly 3 hours before the sun. So it's really a good year to keep an eye on Venus, pay attention to it, where it is, when it is, and it's fun to study, fun to pay attention to it, but from a distance, because we don't want the fate of Earth to follow the fate of Venus. So thank you for joining me today. I will stop sharing my screen.